Today we're going to continue 7-4. This is solving systems of equations. Now you'll notice that this is a little bit different than what we did in the previous video, where in the previous video we were left with y equals something and y equals something, and we could set those two equations equal to each other. Here we don't have that. So by using the substitution method, what I'm going to try and do is I'm going to try and either solve for x, or I'm going to try and solve for y, and then whatever I find that to be, I'm going to substitute it into the other equation. So I think what I will do here, because these two variables don't have any numbers with it, they're easy to solve for, I think I'm going to solve for x. So to be able to do that, let me write the problem down again. So you have x minus y equals 3. To get x all by itself, I would have to add y to both sides. So here, I'm going to get x equals 3 plus y. So once you have one of the variables equal to something, what I like to do is I like to circle it, and then I'm going to substitute that, what I just found, into the other equation. Now since it's x, I'm going to take this whole thing and I'm going to substitute it in for x. So now I need to rewrite. So I'm going to take the 3 plus y, which is what I found right there, plus, and then I'm going to write everything else down in the original equation. So once you have that, then you're going to need to do your combining of variables. So you have y plus 5y, that would give you 6y. Then you're going to have to get rid of the 3, so you're going to subtract 3 from both sides. So you have 6y equals 36. Then you're going to divide both sides by 6, and you're going to get y equals 6. Now, a couple of things that you can do here. You can take this answer that you just found and you can substitute it in one of the two original equations. But since you came over here and you already solved for x, if you would just take this value and substitute it in there, it kind of saves you a step or two. So you have 3 plus 6. 3 plus 6 is 9. You get x equals 9 and y equals 6. So if you want to write it as a ordered pair, you're going to have 9 and 6. So moving on to the next example, same scenario like the first one. We don't have anything that's all by itself, no variable by itself. So if I look at the two equations, I do see that y does not have a number with it. So it looks like that's probably going to be the easiest one to solve for, so that's what I'm going to do. So let me write it down. Let's get rid of the 3x, bring it over to the other side. So you have y equals negative 3x plus 8. So since now I have y equals something, I'm going to circle that. I'm going to take that and I'm going to draw an arrow over to the y, and I'm going to plug that in there. So now I have 6x plus 2. Now since I have a number here, and I didn't have a number in the other one, but since I have a number here, I'm going to put what I found in parentheses, because I'm actually going to have to multiply that out. Go 16. So I'm going to have to use the distributive property. So you have 6x. 2 times negative 3 will be negative 6x. 2 times 8, 16. You're going to combine your like terms. You get here 0. So you have 16 equals 16. Now you can actually stop right there because this is true. It's always true. 16 definitely equals 16. If that's the case, that means that this is an infinite solution problem. It means that everything is going to work. So you're going to put, INF. Oh, that's terrible. INF. Circle that. Infinite amount of solutions. Just to make sure that we get the hang of this. Take a look at it. We could either solve for x up top here, or we could solve for x in the bottom. It doesn't really matter. Let's just go ahead and I guess do the top. So you have x plus 4y equals negative 10. So I need to subtract the 4y from both sides. So you get x equals 10 minus 4y. I will circle that. Since I am solving for x, I'm going to plug in over here for x. I'm going to have 10 minus 4y minus 3y equals 11. Going to combine my y's. So that'll be a negative 7y equals 11. And to get to 10, bring it over. So I'm going to subtract from both sides. So you get negative 7y equals 1. And then you're going to divide both sides by negative 7. And in this case, it doesn't really come out to a very nice number for us. It comes out as a fraction, which may happen. It's not that big a deal. So we have y equals negative 1/7. So once you have that, let's go ahead and bring it up here and solve for x and find out what x equals. So we have x equals 10 minus 4 times what we just found. So you're going to have x equals 10, negative and negative will make that a positive. This will become 4/7. 10 plus 4/7 is 10 and 4/7. Whoops. So you may run into a problem where you do get fractions, and that's perfectly okay. That can happen. So if you get that, don't feel like you made a mistake. And our last example. When I look at this one, I see that the x here does not have a variable, so I'm going to solve for x there. So instead of rewriting it, I'm just going to bring that over. So I'm going to add 5y to both sides. So you have 5y equals, plus 4. Going to take that, and I'm going to substitute it in the top equation for x. One of the things you want to make sure that you don't do is if you solve for one equation, don't substitute it back into that equation. It's not going to work out for you. So let's go ahead and plug it in there. So you have 5y plus 4 plus 10y equals negative 8. So we're going to have to use distributive property here. So you're going to multiply that out. That's going to be negative 10y minus 8 plus 10y equals negative 8. In this case, our y's are gone. So negative 10 and positive 10 give you 0. So you're left with negative 8 equals negative 8. Oh, and here's another problem where the two answers that you found are equal to each other, which is true. So this is going to be another one that's going to be an infinite amount of solutions. Now, it's not always going to work out like that. I think our last example on the previous page came out to this as well. It's not always going to be that way. After you distribute things out, you could end up with, a problem that does have one solution, or it may be no solution. You just have to work it out and see how things come out.